right?
right?
So
So
you can do this
do this
question
question
using
using
find out
find
the
out the
expectation of
expectation of
x.
x.
I mean,
I mean,
you just
you
need
just
to
need to
integrate
integrate
this
this
and
and
this,
this,
right?
right?
So if you
So
do
if you
this
do
2
this
by
2
3
by
and
3
1
and
by
1
2
by
is the
2 is the
answer.
answer.
So
So
these kind
these
of
kind of
questions are
questions are
very
very
relevant to
relevant to
gate
gate
DA.
DA.
In
In
gate
gate
DA
DA
also they
also
will
they
be
will be
asking
asking
similar
similar
kinds
kinds
things of
things of
questions.
questions.
I mean,
I
they
mean,
will
they
be
will be
giving you
giving
some
you some
CDF,
CDF,
oh sorry, some
some
PDF. They
PDF, they
might
might
ask you
ask you
expectation,
expectation,
or they
or they
might ask
might
you
ask you
conditional
conditional
expectation.
expectation.
Okay,
Okay,
so
so
for this
for this
question,
question,
I'm not
I'm not
asking the
asking the
conditional
conditional
expectation, but I
expectation,
will
but I will
definitely
definitely
ask the
ask the
conditional
conditional
expectation
expectation
in the
in the
next
next
AIMT.
AIMT.
Okay,
Okay,
so in the
so in the
next
next
AIMT, I
AIMT,
will
I
be
will be
asking you
asking
the
you the
conditional
conditional
expectation
expectation
and
and
PDF will
PDF
be
will be
given for
given
the
for the
continuous
continuous
random
random
variable. Okay,
variable. Okay,
I will be
I will be
asking the
asking the
conditional
conditional
expectation.
expectation.
Okay,
Okay,
now let's
now
solve
let's
this
solve this
question.
question.
In this
In this
question,
question,
they are
they are
saying the
saying the
covariance.
covariance.
They are
They are
see
see
again.
again.
I have
I have
given
given
lot of
lot of
hints in
hints
this
in this
question.
question.
Hint in
Hint
the
in the
sense
sense
it
it
is
is
not
not
directly the
directly the
hint,
hint,
but
but
the
the
hint
hint
to make
to
sure
make
that
sure
you
that
at
you
least
at least
probably
probably
remember the
remember the
if you
if you
even
even
don't
don't
remember the
remember the
formula, I have
formula, I have
given the
given the
formula,
formula,
right?
right?
So this
So this
formula is
formula is
given
given
here,
here,
and
and
also
also
uncorrelated
uncorrelated
meaning is
meaning is
given.
given.
They can
They can
easily
easily
skip
skip
this
this
meaning.
meaning.
They do
They
not
do
need
not
to
need
give
to
this.
give
They
this.
do
They
not
do
need
not
to
need
give
to
this.
give this.
They can
They can
directly say
directly say
this.
this.
Okay,
Okay,
they can
they can
directly say
directly say
this
this
because
because
these are
these are
inferred
inferred
things.
things.
Okay,
Okay,
they do
they
not
do
need
not
to
need to
give these
give these
things,
things,
right?
right?
Okay,
Okay.
so
So
covariance
covariance
of
of
two
two
random
random
variable
variable
xi and
xi and
xj is
xj is
zero
zero
actually.
actually.
Okay,
Okay,
if they
if
are
they are
uncorrelated.
uncorrelated,
Okay,
okay,
that's
that's
fine.
fine.
They are
They are
pairwise
pairwise
uncorrelated. So
uncorrelated. So
now they
now
are
they are
asking you the
asking you the
correlation
correlation
between
between
these.
these.
Okay,
Okay,
so
so
basically
basically
you
you
don't need
don't
to
need
worry
to
about
worry
the
about the
correlation.
correlation.
You
You
just need
just
to
need
worry
to
about
worry
this
about this
covariance and
covariance and
variance
variance
because the
because the
formula is
formula is
given to
given
you.
to you.
Find out
Find
the
out the
covariance
covariance
between these
between
two.
these two.
Find out
Find
the
out the
variance of
variance of
these
these
things,
things,
right?
right?
So let's
So
just
let's
do
just
this.
do this.
So
So
covariance
covariance
between these
between
two
these
will
two
be.
will be.
I mean,
I mean,
since we
since
have
we
done
have
these
done
kind
these
of
kind of
things
things in
in the
the
class
class
already,
already,
so
so
that's why
that's
I'm
why
just
I'm just
going
going
through the
through the
formula.
formula.
Okay,
Okay,
here.
here.
So
So
it will
it
be
will be
x1
x1
will be
will be
paired with
paired with
x2 and
x2 and
x3.
x3.
So
So
basically
basically
x1,
x1
x1,
x1
x2,
x2
x1,
x1
x3,
x3
and this,
and this,
right?
right?
Now we
Now
know
we
if
know
this
if
is
this is
basically
basically
if this
if this
is
is
not
not
equal. I
equal. I
mean,
mean,
since they are
since they are
uncorrelated, so
uncorrelated, so
that's why
that's
it
why
will
it
be
will be
just
just
x2
x2
x2.
x2.
Okay,
Okay,
which is
which
the
is the
variance of
variance of
x2
x2
only,
only,
which
which
is
is
given as
given
to
as
be
to be
1
1
because they
because
are
they are
saying
saying
that
that
variance is
variance is
1
1
for
for
all of
all
these
of these
random
random
variables,
variables,
right?
right?
So this
So
is
this is
anyway
anyway
given to be
given to be
1.
1.
Now,
Now,
now
now,
basically
basically,
basically
basically
this
this
whole
whole
quantity is
quantity
1,
is 1,
right?
right?
Now you
Now
just
you
need
just
to
need
find
to
out
find out
variance of
variance of
x1,
x1,
x1
x1
plus
plus
x2
x2
and
and
variance of
variance of
x2 plus
x2 plus
x3.
x3.
So the
So the
formula is
formula
this.
is this.
Okay,
Okay,
variance of
variance of
x1 plus
x1 plus
x2, this is
x2,
the
this is the
formula.
formula.
Variance of
Variance of
x2
x2
plus
plus
x3, this
x3,
is the
this is the
formula.
formula.
If you
If you
apply the
apply the
formula,
formula,
this is
this
one
is one
given, this
given,
is
this
one
is one
given,
given,
and this
and
is
this is
also
also
given as
given as
0,
0,
right?
right?
This is
This is
1,
1,
1,
1,
and this is
and this is
also
also
given as
given
0.
as 0.
So
So
both of
both
these
of
are
these are
2.
2.
So
So
again, you
again, you
can
can
just do
just do
this
this
easily.
easily.
1
1
upon 2
upon 2
into
into
2
2,
square root,
square root, which is 1
by
by
2,
2.
right? So
Right?
B
So
is the
B is the
correct
correct
answer.
answer.
It
It
was
was
also
also
the
the
good
good
question, I
question, I
can say,
can say.
right?
Right?
Okay,
Okay.
so
So
don't
don't
worry.
worry.
So
So
मैं
मैं
saying
saying
मैंने ये
मैंने ये
गलत कर
गलत
दिया.
कर दिया.
So
So
don't
don't
worry.
worry.
See,
See,
that is
that is
fine.
fine.
Reason is
Reason is
that
that
this was
this was
just
just
first
first
AMT.
AMT.
Okay,
Okay.
this was
This was
just
just
first
first
AMT.
AMT.
So we
So
will
we
be
will be
having
having
more
more
AMTs.
AMTs.
Most
Most
probably we
probably
will
we
be
will be
having
having
5
5
AMTs,
AMTs,
right?
right?
So if
So
we are
if we are
having
having
5
5
AMTs and
AMTs
this
and
is
this
just
is just
first
first
AMT,
AMT,
so
so
don't
don't
worry. I
worry.
mean,
I
this
mean,
was
this was
just to
just to
make sure
make sure
that you
that
are
you are
having
having
spending
spending
3
3
hours,
hours,
along
along
in the I mean,
I mean,
you are at
you are
least
at
able
least
to
able to
sit
sit
3
3
hours. You are
hours. You
at
are
least
at least
able to
able to
have
have
some
some
focus.
focus.
You are
You
at
are at
least
least
able to
able to
recall
recall
some
some
things.
things.
Okay,
Okay.
so
So
we will
we
be
will be
having
having
multiple AMTs, and you will be basically very much comfortable after the 5 AMTs with the full length test, right? Okay. So this was one tricky question that I can say most of non-Go classes students may fail in this question. Okay, so this was very nice question. I can say tricky or the nice question. Okay. Specifically because of this option, stochastic gradient descent is guaranteed to eventually converge. Okay. So we have seen stochastic and the gradient batch gradient descent. So in stochastic, basically this is very much fluctuating because it is based on just one example. So see here, batch gradient descent is very static. Mini batch is still, let's suppose I'm starting from here. Minimage is like this. Stochastic is very much unfluctuated. It is too much fluctuating, right? Stochastic. So, by the way, this is also in our YouTube channel. I mean, these lectures, stochastic and all. So you can just see these lectures, right? I have solved 30 questions regarding the batch gradient descent and all of this. So you can check these lectures in our YouTube channel if you are not familiar about these concepts. Okay. Now let me move forward. What I'm trying to say. Yeah. So basically, maybe you can see here it is Stanford, right? Can you see this particular slide? So basically, this is a slide again from the same lectures, from these YouTube lectures. Okay, you can see these lectures. So you can see that I've solved these kind of questions, and this question is from Stanford, right? That I've earlier solved. And now you just see the option number C. Okay. Is it always guaranteed to converge? So in the Stanford also, the answer is no. The stochastic is not always guaranteed to converge, even if it is convex or something like this, right? Doesn't matter. Okay. Why? Because stochastic is actually very much fluctuating. So I cannot guarantee. There is no theoretical proof of this. For stochastic, there is no theoretical proof. Because you can keep on fluctuating. For every example, there will be some different, update. Okay. For every example, there will be some different update. You are getting my point? So that is why stochastic is guaranteed. So actually for the details you can check these lectures. Okay. Because since it is just a question solving, I cannot go through the whole concept and all. So you can go through these lectures for the details. Okay. So yeah, is this stochastic guaranteed to converge? That is the crux of this question. So answer is no. Right. I mean stochastic is not guaranteed. Will eventually converge? No. And gradient descent, if it is convex, then gradient descent will converge. Okay. So what is the answer? A is the answer, right? Gradient descent will converge, but stochastic will not converge. I mean, it is not guaranteed to converge.
Converge and a straight line, huh?
Right? If that is just a luck. So Nikhil is saying that if the initial point itself is a minima, that is just a luck. I mean, in that case. Yeah, in that case, obviously, like your minimum, if that is minimum, then your grade is 0, right? Already your grade is 0, you will not even run even one iteration, right? Because your grade is 0. You will not even run even a one iteration. I mean, if everything is satisfied. If grade is 0, then this is necessary and sufficient condition. Okay, because the function is convex itself, right? You will not even run even a single iteration of any of the algorithm. So this was a nice question, I can say. Okay. Now let's solve this question. In this question, they are saying that there are like two, data. I mean, two same data, but Alice is recording in some different units, and Bob is recording in some different units, and they resultant, data is looking like this. I mean, A, B, C. They are saying these are the two features. I mean, these are the two features and three examples. So these are the three examples: A, B, C, P, Q, R. There will be some Y. Okay, I mean, I'm not writing the Y, but yeah, one of the table is A, B, C, P, Q, R. Another table is 2A, 2B, 2C, 3P, 3Q, 3R. Right? Okay. Now, how many of you found this question nice? We have solved these kind of things in the class also. We have talked about these kind of things in the class also. How many of you remember, or how many of you were able to solve this question in the class, in the exam? See, what is happening here? We have two of these tables, right? Now they're asking about the weights if we train using a linear regression. So obviously, the weights will be different, right? I mean, whatever weight I'm learning here, okay, will be different. Why? Because here, let's suppose this is x1, x2. Here, so basically what I'm saying that w1 x1 plus w2 x2. Okay, it is giving you some y cap. Now, if this was, let's suppose w1, whatever was the w1, so x1, because of x1 it will be, for the first example, W2P, right? Then it will be bi-cap. For the first example, this is the case. Now, here in the Bob table, this is for the allies. Right? This is for the allies. Now in the Bob table, you will be having the same things. Okay. But little different. How? Let me just tell you. See, if it is Bob, then you will be having W1x1. Okay, plus W2x2 equal to same y1 cap. But here, this W1, it could be little different, but don't worry about it. I will just adjust it. Okay. W2, 3P, right? So it will also give the same y1 cap. It can easily give. Why? Because W1 can adjust itself. How? W1 can be here. If it is W1, then it will be W1 by 2. If it is W2, then it will be W2 by 3. Right? So basically W1 here if it is W1, if this is giving you W1, then it will be giving you W1 by 2 and W2 by 3. Right? It will be giving you this solution. Because y has to, I mean, they can easily map with the y. I mean, they can easily, this can easily produce the same y1 cap, this can easily produce the same y1 cap. I mean, their prediction will not be different. Their weights will be different. Since the predictions are not different, that is why the loss will be same. Because the predictions are not different, loss will be same. Okay? I mean, since the linear regression, it is easy question, don't worry too much. Since the linear regression can easily adjust the weights. I mean, if you are introducing some linear features, you are tweaking the linear features. If you are introducing linear features, your loss will not change. Your weight will adjust such that your loss will not change. Okay? So you can say in one line, your weights will adjust such that your loss will not change. I mean, you will be anyway finding the optimal solution here. Here also optimal solution. Okay? So weight will adjust such that your loss is not changing. Right? So weights will be different, but loss will be same. So what is the answer? C is the correct answer, right? It was really a nice question according to me. Okay. Yeah. So, thank you Krishna. So Krishna is saying सर मैंने टेस्ट सीरीज ली है and वो बहुत ही अच्छी है. So thank you so much for your feedback.
Now, define converge in gradient descent.
In gradient descent, converge means that the optimization algorithm has reached a point where the updates to the model parameters become very small, essentially signifying that the algorithm has found a minimum value of the loss function, and further iterations will not significantly change the result, effectively stopping at a stable point on the error surface, which could be a local or global.
Which is more converge, gradient descent or sophisticated gradient descent?
So you after the first means. So if you update mean, then how will it look like? So these are the clusters. Okay. So this particular point. Just a second. Okay. This maybe actually if I just do cut here, it will be black background, but I think actually the mean of the first cluster will be here, the mean of the second cluster will be somewhere here, right? Is this okay everyone? And these will not be any longer mean. Okay. So basically after mean update, these are not the means. I hope you understood a little bit what I'm trying to say. Okay. So basically, what I'm trying to say is that means will get updated. So mean will be this now. Mean will be this now. Is this okay, everyone? No, this is the cluster. This is the converge. Okay, this has been converged. Okay, there will not be any mean change. Okay, just one iteration. After only one iteration, only after one iteration it will converge.
ఒక ఇరిటేషన్కే కన్వర్జ్ అయిపోయిందా? యా అయ్యింది.
Right. Only after one iteration it will converge. Yes. So there was there was very good topic wise tests also. Okay, to improve the concept. So you can solve those questions first before attempting the IMPs, because in the topic wise test we have actually covered many of these things, right? Okay. So what I'm trying to say here is that that this is just a converse thing. Now they're asking about the loss function, right? I mean, what is the value of loss? So what is the k-means loss? K-means loss is very interesting. It is basically inter-cluster loss, in the sense that, sorry, intra-cluster, we might call it inter-cluster, in the sense that within this cluster only, okay, for this cluster only, what is the loss? For this cluster only, what is the loss? In the sense, how much it is far from this mean. Since the mean is in the center, so it is 1, right? So it will be like 1 square plus 1 square. It is also one distance, 1 square, 1 square. So basically, if you check 1 square plus 1 square for first cluster, 1 square plus 1 square for the next cluster. Okay, for C1, for C2. So finally, 4 is the answer. Okay, I mean, this will be just 1 and 1, 1 away, then 1 away. Okay, I mean, from the mean, how much away it is from its own mean. I will not be finding the distance from this to this mean. This is wrong. Okay, I will be just finding the distance. This is k-means loss. This is taught in the class very well. Okay, this is very well taught in the class that k-means loss is within that cluster only. Okay, so how much far it is from its own mean. Okay, so basically this mu j is for this own mean. Okay, how much far it is from its own mean. This was taught in the class. So these are the 45 questions, which I think number is 45 now. So let's just solve the remaining questions later on. Okay, because otherwise the session will be too long. Okay, I think we have already spent almost 2 hours. So let's just solve the remaining questions in the next session. I will just tell you the timing, okay, for the next session. But let's just solve the remaining questions. So I think 20 questions are remaining. Out of that, for my subjects, maybe AI video solutions are already uploaded. Okay, for AI questions, let me just tell you, for AI questions, video solutions are already uploaded. Okay, for example, question number 50. Okay, just a second, let me just paste you, and let me just show you, let me just paste you the screenshot. Let me just show you that what I mean to say. Okay, if you check under the AI questions, so we have already uploaded, we have already commented about the video solution, the AI question, video solution. Okay, so for every AI question, for example, this is a comment under question number 50. Okay, this is a comment under question number 50. So for every AI question, we have already commented. Okay, comment under question 50, you will find this particular thing. Okay, under question 50 you will find this comment. Okay, so for AI questions, the video solutions are uploaded, and then I will just solve the remaining questions, whatever the remaining number of questions. I think maybe around 15 questions might be remaining. Okay, from my subject. Okay, around 15 questions that we will be solving in the next session. Okay, so thank you everyone, thank you for watching this session, and then let's just meet in the next session very shortly. Yes, AI questions were actually very good. Can you tell me the feedback of the AI class? Okay, I mean, are you enjoying the AI particularly lectures? If you're enrolled students, then can you tell me, are you enjoying AI lectures? How was the AI lectures? Okay, and how was the class? Just let me know quickly. Okay. Yes, the PDF of this I will upload. Okay, PDF of this particular session I will upload. Okay, just after the class. Okay. So thank you everyone. Thank you so much for watching the session. Let's just quickly meet in the next session. Okay. Thank you so much. Take.
గ్యాస్ రిపేర్ అయిందంట 200 అయింది